Good evening, everybody. So today we are explaining the object detection, and in this we worked on person detection for surveillance.
Right. So in object detection, we know that we have to identify the objects in the image of the video as well as locate them inside, as in draw the bounding boxes around them. So we specifically focused on person detection for surveillance. How we started this was first we went to various research papers which were having pre-deep learning techniques for object detection, such as the sliding video object detection using HOG and SVM. In this we use the HOG features to, and then these extracted features are used for classification, and the classification is done using SVM for every window. Then onwards we moved on to deep learning techniques.
For the deep learning techniques, we went through the family of RCNN, in which we go through the fast RCNN and mask RCNN, which was basically developed in 2015 and 16. But later on, when the SSD came, and these are like SSD single shot detector and the YOLO. So these things like works very well and overbeats that RCNN family. And basically, this RCNN family comes in two-stage detection, where it like classify object in a second stage, but the YOLO and SSD comes in a single stage detection, which directly classify in a single shot, right? And in the YOLO, and now whatever the SOTA is presented, so that are YOLO V8, and it is like working so good in a field of object detection.
We actually went through various types of YOLO versions available, like YOLO V5, V7, and V8. Initially, what we did was we took one YOLO V5, which was already pre-trained on COCO dataset, and since we had to do person detection for surveillance, we found a top view dataset which had people inside the image, and we ran just the pre-trained models on these images. The results were shockingly poor, and then we discussed that what could be the reason for these results. So we can see the results in figure 1. Like we can see in figure 1A part, the pre-trained YOLO V5 is hardly detecting any persons in that image. As well as in B image also, here we can see that it's just detecting one person. So we discussed what could be the reasons behind these bad performances. So we came to a conclusion that since it's been trained on COCO dataset, which contains most of the images as front view images, and this test dataset which we are testing on is a top view dataset. So hence we concluded that that is the main reason behind the poor performance. So in the next step, we trained the YOLO V5 model on our existing top view dataset, and the results can be seen in figure 1 part C and D. Now over to Bhagwari.
So these are the results when we like train our model on the person dataset. So it's like an open source dataset, and we have described already here. So it consists a lot of images, and for the same we train a model, and now we can see the person which was not detecting in the pre-trained YOLO V5. Now we are able to detect this thing, right? And for the like comparative analysis, we did the same. We took a one photo and tried to compile on every YOLO version. So it was an image one where it was like try to like when we were just detecting the person in this image, we're hardly able to detect because the COCO basically because the YOLO V5 trained on COCO dataset, which is basically a front view kind of a dataset, and it is not trained on the aerial kind of dataset. So now it is detecting the plotted plant it's good, plotted plant it's good, but not able to detect the human. So it was a pre-trained YOLO V5. So followed by this, so we trained it on YOLO V5, and on the same image we try to detect, and when we like train our model with that dataset, so now we are able to detect the person.
So already YOLO V5 trained on the top view dataset is performing much better than the pre-trained one. Then we moved on to YOLO V7 and trained it on our top view dataset. The performance is pretty good for YOLO V7 also, and it is in fact detecting one extra person which was being missed out on the YOLO V5 model. And then we did the same exercise with YOLO V8, and the performance came out to be pretty good for this case. So finally, we have done a comparative analysis of all these YOLO models, and in table 2, we can see the performance metrics for these models. The performance metrics which we have considered are basically average precision and MAP, that is mean average precision, and we have explained what is precision, recall, IOU, and everything in the report itself. The comparative results of the YOLO models can be seen in table 2. In this table, we can see that although all the models are performing pretty well on this final dataset which we've taken, but YOLO V8 comes out as the winner amongst these three models and having the highest MAP 50 as well as MAP 95 value. So on a concluding remark, we have done a comparative study of various deep learning models, specifically different versions of YOLO, for detecting persons in images. We have done this because our aim was to make person detection for surveillance as a complete tool, and the results are in line with whatever research papers we went through. That is, YOLO V8 performed the best, and the pre-trained ones were performing very poor as compared to the new trained ones on the new top view dataset. Hence, the results are completely in line with whatever research papers we went through. And in the end, we also dabbled a little bit into person re-identification problem, but we are still working on it. That's it.